Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into the essence of quantum mechanics in the enigmatic and beautifully written book Helgoland by Carlo Rovelli. Our journey through this work reveals the perplexing and often counterintuitive nature of the subatomic world, where certainty gives way to fascinating probabilities and where the fabric of reality challenges our everyday experiences. Carlo Rovelli, an acclaimed theoretical physicist and director of the Quantum Gravity Research Group at the Centre de Physique Théorique in Marseille, France, uses his expertise to guide us through a realm where concepts of space, time, and matter intertwine in unexpected ways. He has captivated readers worldwide with his outstanding ability to translate complex scientific concepts into language that resonates with a wide audience, as evidenced by his previous bestsellers, including 7 Brief Lessons on Physics, Reality is Not What It Seems, and The Order of Time. Helgoland is a must-listen for amateur physicists drawn to the wonders and history of science, psychonauts venturing into the curious depths of atomic realms, and anyone who is eager to embark on a mind-bending exploration that transcends the boundaries of their perception of reality. Join us as we distill the intriguing ideas of this remarkable book into a concise narrative and prepare to have your understanding of the world fundamentally transformed. Helgoland, Making Sense of the Quantum Revolution. Introduction. Discover the birth of quantum mechanics on a breezy island. Picture Werner Heisenberg, just 23 years old, on a quaint North Sea isle, wrestling with sneezes, only to stumble upon ideas that would forever change the fabric of physics. It's a narrative sculpted by nature's very own antihistamine, where Helgoland's crisp air provides more than just respite from hay fever. It becomes the cradle of quantum mechanics. Join us as Carlo Rovelli, master physicist and storyteller, unveils this enthralling tale of scientific discovery and intellectual adventure. Heisenberg's retreat from pollen to pondering atoms leads to an unveiling of reality itself, challenging notions we've held for centuries. In our journey through this narrative, you will uncover how a seemingly mundane malady catalyzed a monumental leap in physics, the enigmatic nature of objects at the subatomic scale, defying common understanding, and the compelling case against the need for multiverses in explaining our universe's mysteries. Stick with us as we explore the peculiar, paradoxical world revealed by quantum theory. A journey that starts with a sneeze and ends with questions that continue to perplex and inspire today's brightest minds. Part 1. The Conundrum at the Heart of Quantum Leaps. As the dawn of the 20th century embraced scientific curiosity, Werner Heisenberg and his contemporaries were captivated by the bizarre behavior of atoms. A particular quirk had them scratching their heads. Atoms, when excited, emitted light only at certain frequencies, akin to a musician playing only specific notes on a scale. This pointed to electrons, the minuscule particles within an atom, preferring some paths around the nucleus over others, an idea backed by the observant Niels Bohr. Now imagine young Heisenberg, grappling with questions that danced around the peculiar behavior of electrons. Why do they circle in distinct orbits, and why do they hop between these fixed paths in such precise ways? In wrestling with the mechanics behind these quantum leaps, he stood at the precipice of pioneering a new, intricate realm called quantum physics. Let's distill the essence of this epiphany. Heisenberg propelled the advent of quantum physics, a domain teeming with complexities. What confounded scientists back then was the unpredictable behavior of electrons. Utilizing the variables of classical physics, such as position or velocity. To peg down an electron's movements was like trying to catch smoke with your bare hands. Only the transitions these particles made, observed through changes in light's frequency and amplitude, offered any kind of measurable certainty. Heisenberg maneuvered around this enigma by discarding the unobservable. Like an artist preferring brushstrokes over precise lines, he re-envisioned classical physics introducing matrices. These mathematical entities captured the multitude of potential transitions an electron could make, aligning stunningly with Bohr's observations despite their daunting complexity. Simultaneously, Erwin Schrödinger embarked on an alternate trail. He viewed electrons not as mere particles playing tag around the nucleus, but as waves rippling through the space. His approach, wielding the mathematics of waves, echoed Heisenberg's success in explaining the behavior identified by Bohr. Yet, a conundrum lingered. Waves, by nature, spread out, but detectors showed electrons as definitive points. Enter Max, born with the puzzle piece that harmonized this discord. Heisenberg's matrices, he argued, revealed the consequences of observing electrons. Conversely, Schrödinger's waves estimated the likelihood of such observations coming to pass. In a reality painted by quantum physics, electrons existed as waves with countless possibilities until an observer came into the picture, causing them to coalesce into a discernible location. But this twist in the tale left a trail of questions, with one particularly puzzling one. Why does this happen? How do observation and reality intertwine in the quantum dance of particles and waves? The stage was set for further inquiries deep into the essence of reality, strumming on the strings of quantum mechanics. Part 2. Exploring the puzzling paradox of Schrödinger's cat. Picture this: a cat, a box, and an exotic atom-triggered sedative dispenser. Ingredients for a thought experiment that places our furry friend in a peculiar limbo. This is the realm of the quantum, where an atom's unpredictable decay plays roulette with the cat's state of consciousness. Until the box's lid is lifted, the creature hovers in a strange twilight zone, simultaneously dozing and alert. This is the essence of a quantum superposition. Such superpositions are more than just theoretical conundrums. They raise profound, perplexing inquiries into the nature of reality itself. The riddle goes like this: superpositions challenge our understanding of what's real. Conceived by Erwin Schrödinger, this eponymous cat experiment prods at quantum physics' core enigma. Despite the bizarre concept of superpositions sounding like the stuff of fantasies, they're deeply ingrained in scientific observation, like a photon of light meandering down two paths at once. To untangle this knotty thread, a tussle of interpretations has emerged. Imagine a universe, or rather universes, burgeoning from each quantum event, branching out like the limbs of an infinite tree. This is the many worlds theory, where the cat's dual state isn't merely theoretical, it's concretely reflected in parallel worlds. In this kaleidoscopic reality, there's a version of you witnessing each possible outcome of every quantum event. In stark contrast to this vision of countless cosmoses is the hidden variables theory, firmly rooted in a singular reality. It distinguishes the probabilistic wave of Schrödinger from the actual behavior of a quantum entity. The theory suggests there are unseen forces or properties guiding quantum outcomes, shrouded from our current scientific grasp. Thus, the probabilities in play would reflect an underlying structure we've yet to decode. Then there's quantum Bayesianism, commonly known as QBism, carving out an entirely unique narrative. This view sees superpositions and the probabilities in predictions, like those in Schrödinger's wave function, as subjective, mere snippets of information at our disposal. It's not until we pry open the box and let our gaze rest upon the cat that we gather more data, sharpening the contours of reality. The observer, under QBism, stitches the fabric of the universe one observation at a time. This begs the provocative question: who or what qualifies as an observer capable of sculpting reality? Engage with this tapestry of theories, where the cat's paradox stands as a testament to our quest to comprehend the enigma of quantum mechanics, each interpretation a different lens through which to behold the grand design of our existence. Part 3. Quantum Mechanics and the Relational Dance of Existence. Traditional views on quantum mechanics paint a picture where superpositions are a mystical territory, remaining veiled in probability until the watchful eye of an observer steps in. In this perspective, it's as though the observer holds a magical key, their presence alone enough to collapse clouds of potential into a single manifest reality, a single pinpoint in space, where an electron ceases to dance around possibilities and takes a stand. Yet, what bestows upon this observer the unique badge of reality maker? Is it their consciousness, their tools, or perhaps something else entirely? No, the secret does not lie in the lab coat or the mind behind the microscope. In the relational interpretation of quantum mechanics, something far more essential is at play: the act of interaction itself. Here's the crux of the matter. The relational interpretation envisions a universe constantly in motion. We have long used the term observation to imply a division between the observer and the observed, a person standing outside, looking in upon a world of physical phenomena. But the relational interpretation shatters this construct. This interpretation envisions the celestial dance of the universe where everything, photons, rainbows, felines, and nebulae, are interlinked in perpetual interaction. Each participant assumes the dual role of observer and observed, giving rise to properties through their relational ballet. Consider a universe where isolated existence holds no meaning, a universe where properties emerge only through the connective tissue of interaction. Much like how the notion of velocity surfaces only through the relationship of objects in motion, all physical attributes are relational. They ebb and flow like tides, shaped by a moon's embrace. This notion tilts our understanding of existence, making the relational perspective appear almost revolutionary. Take the curious case of Schrödinger's cat, sleeping or alert within its container. To the trigger mechanism inside, the cat's state is clear-cut. Yet to you, an outsider peering in from beyond the box's confines, it lies in a state of neither. Different frames of reference, differing interactions, spawn differing versions of reality. Everything is in motion, everything is related, and everything is perpetually defining and redefining existence. Part 4. Entanglement and the Web of Relational Reality. Under the spellbinding sky of quantum mechanics, two photons commence a journey, each enveloped in a superposition reminiscent of Schrödinger's famous feline. They are simultaneously red and blue. Not until we cast our inquisitive gaze upon them do these photons choose their hue. Yet here's the mind-bending twist. We send them on separate paths, one to the historic streets of Vienna, the other to the bustling heart of Beijing. Upon revealing the color of the photon in Vienna, let's suppose a crimson glow meets our eyes. By the quirky laws that govern traditional quantum mechanics, this should somehow dictate that its entwined partner in Beijing would mirror this result a mere 50% of the time. But the outcome defies these odds. The Beijing photon is red as well, unerringly. This peculiar connection is the phenomenon known as quantum entanglement. Here comes the intriguing insight. The relational interpretation sheds light on the enigma of quantum entanglement. Quantum entanglement, a most peculiar aspect of physics, posits that two particles can be so deeply linked that they share a common fate, no matter the expanse that divides them. While a separated pair of red mittens would independently retain their color in any location, our dual-colored photons remain in a probabilistic haze until the moment of observation. How, then, does one instantly echo the state of the other upon revelation? One might imagine a stealthy signal flitting between the photons faster than light itself. But this notion crashes against the unyielding wall of relativity. Could they, perchance, have settled their colors before parting ways? This, too, unravels under scrutiny, with mathematics, the stringent Bell inequalities shaking their numerical heads. Enter the relational model. It paints properties as transient, born from interactions. No onlooker can simultaneously be in both Vienna and Beijing, and thus each photon to the other remains a chameleon in limbo, devoid of true color. The moment of observation in Vienna casts the photon in a vermilion hue, but to the Viennese observers, Beijing, and all it contains, still swims in the quantum fog of potential. This chain of entanglement can be pulled taut through interaction. A scientist in Vienna reaching out across the globe to confer with her colleague in Beijing intertwines their observations, weaving a connection that spans continents. No longer a riddle of mystical links, but a tapestry of relational threads, entwining the properties and phenomena of our bewildering universe. Part 5. The interplay of philosophy and science shapes our understanding of reality. Unsung in popular culture, yet a leviathan in intellectual circles, meet Ernst Mach, the man whose profound musings resonated through disciplines as disparate as politics, literature, and the rigid structures of physics. His insights compelled leaders like Lenin to reach for their pens in ardent critique, influenced the literary landscapes of Robert Musil's masterpieces, and nudged at the ingenious minds of Einstein and Heisenberg, nurturing their groundbreaking forays into physics. What did Mach espouse that cut such a broad swath across various arenas of thought? His proposition was both simple and profound. Our world is constructed not of immutable matter, but of sensations, an idea that harmonizes with the relational quantum theory. The thread to follow here is that the bonds between philosophy and science are intrinsically linked, intricately woven into the very fabric of our comprehension of the cosmos. In the centuries prior, science walked hand in hand with mechanism, a philosophy positing a universe of cogs and gears, a grand, orderly machine operating within the void of space. Yet Mach perceived this paradigm as an intellectual straitjacket, an abstraction veering from the tangible. His call was for science to pivot towards the palpable, the sensations birthed when entities interact, the observable tides of experience. This pivot is not merely a historical footnote. It was the spark that ignited Heisenberg's journey into the heart of quantum mechanics. And the reverberations of Mach's thinking do not stop there. He visualized a cosmos where objects and their properties emerged not from some internal blueprint, but in the crucible of interactions, a view that echoes in the relational stances of modern quantum theory. Mach, while not clairvoyant of the intricacies of quantum mechanics, illustrates the invaluable dance between scientific discovery and philosophical introspection. Without his rejection of the mechanistic doctrine, Heisenberg might not have ventured into the quantum realm. Meanwhile, modern-day philosophers grapple with fresh scientific revelations, using them as whetstones to hone theories that slice more cleanly to the heart of reality. Branching from the intricate relationship between science and philosophy, we're led towards a subject that weaves complexity into every facet of its being: consciousness. Stay tuned as we delve deeper into this intricate tapestry, where the bend of philosophy and the weave of science converge. Part 6. Connections and the curious workings of our consciousness. Quantum quackery populates the digital landscape, where the esoteric allure of quantum physics lends itself to an array of spurious claims. From the promise of spiritual awakenings to the dubious benefits of quantum wellness, the eccentric mystery of quantum science seems to fire up the imagination and fuel entrepreneurial zeal. But does the realm of quantum mechanics hold the keys to unlocking life's deepest mysteries? Can it decipher the enigma of love, decode the essence of beauty and truth, or carve a path to enlightenment? Instead of offering direct answers, a quantum-inspired exploration into relation and correlation can weave intriguing theoretical pathways, particularly when it comes to probing the intricacies of consciousness. The illuminating thought to consider is this: pondering relationships and correlations could cast new light upon the mechanics of the mind. Philosophy presents us with three primary frameworks for conceiving the mind. There's dualism, painting the mind as a distinct reality, untethered from the earthy vessel of the body. Idealism proposes a universe enveloped by the overarching expanse of the mind. And then there's naive materialism, which simplifies thought and awareness to mere byproducts of physical interactions. When viewed through a lens refined by relational quantum theory, the mind gains a fresh narrative. Delving into meaning, a significant aspect of human cognition, we encounter the concept of intentionality, as introduced by philosopher Franz Brentano. The idea that our thoughts and perceptions are inherently directed towards something beyond themselves, something external. Consider how intentionality could emerge from a quilt of relevant relative information. This type of information is a correlation birthed from the dance between systems. Envisage observing a stone plummeting towards you. The external entity, the stone in freefall, and the internal state, your brain processing this event, interlink, generating a meaningful correlation, compelling your body to sidestep the imminent collision. Here, the information woven through external and internal interactions spawns intentionality. The plummeting stone spells danger, and you instinctively evade it. This model manages to map out the physical processes, stitching together the interactions of various systems. However, it leaves untouched the personal, subjective vista of your near miss, the very texture of experience itself. This challenge, known as the hard problem of consciousness, keeps the question of how subjective experience arises tantalizingly open and ripe for fervent discourse. Part 7. Quantum insights offer a novel kaleidoscope for viewing existence. Gaze upon a feline friend, and you might believe that what you're seeing is a straightforward process. Light reflecting off its sleek coat, captured by your eyes, and deciphered by your brain into the familiar image of a cat. Yet, this conventional understanding doesn't entirely capture the intricacies at play. In truth, your brain orchestrates a symphony of expectation and perception. Rather than being passive receivers, your eyes relay to your brain any visual information that deviates from what your brain anticipates you should be seeing. This dynamic interplay results in a concerted dance between prediction and reality, demonstrating how pivotal discrepancies are in shaping our understanding of the world. The profound lesson here is that delving into quantum physics prompts us to reconceptualize our view of the universe. Emerging from the intriguing doctrine known as the projective consciousness model, this alternative vision of sight depicts consciousness as the product of the brain's relentless comparison between its internal forecasts and the sensory data flooding in. Our grip on reality, therefore, is akin to a continually confirmed hallucination, ever shifting and adapting. Reflect upon the broader spectacle of scientific exploration, and you'll find echoes of this same pattern. Each epoch crafts a mosaic of the cosmos, only to have it interrogated, dissected, and occasionally dismantled by the inexorable tide of discovery and innovation. Unlike the near-instantaneous cerebral updates, science meanders through these revolutions with the collective pace of centuries. Our contemporary quantum theories, including the relational interpretation, are merely the latest evolution in this grand narrative. These theories represent our closest approximation to the universe's secrets, as far out and uncanny as they might appear. In the theater of relational quantum mechanics, the universe sheds any notion of stability and constancy, revealing itself as an intricate lattice of interactions, a shimmering tableau where phenomena coalesce and fade without cease. Even the essence of who we are, our individual narratives and very subjectivity, is intricately intertwined within this dynamic maelstrom of connections. Embracing this perspective might feel alien or even somewhat hallucinogenic, but in the court of scientific inquiry, this is the vision currently borne out by evidence. As we stand at the precipice of these quantum revelations, let us step forward, willing to let our confirmed hallucinations guide us into the ever-unfolding mystery that is our universe. Final summary. Quantum mechanics, a field that emerged in the early waves of the 20th century, did not just tinker with the edges of scientific thought. It heralded a paradigm shift. A vanguard of audacious young physicists, with Werner Heisenberg at the fore, embarked on a revolutionary journey that shook the foundations of classical physics to their core. The mechanistic universe, once perceived as a predictable clockwork of deterministic movements, gave way to a landscape where certainties diffused into probabilities and absolutes into uncertainties. These blinks unfurled the canvas of a quantum world as envisioned by the relational interpretation, a universe where existence does not hinge on static entities but thrives in the unpredictable ebb and flow of relationships. This quantum narrative defies intuition, suggesting that what constitutes reality is neither fixed nor universal, but is instead subject to the ongoing dynamism of interactions. In this remodeled quantum cosmos, the concrete molds of conventional physics melt into a spectrum of potentialities, each vying for actualization, framed by the ever-changing context of their relational networks. We occupy not a universe of lonely, discrete objects, but rather a vibrant symphony of interconnected occurrences. With each novel relation, the symphony evolves, and what is considered real is perpetually redefined. Embrace a revolutionary perspective where the universe is not a colossal machine, but a quantum web of ceaseless interactions. A place where what's true for one might differ from the next, all dependent on how the strands of reality intertwine. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.